So in grade 10 and 11, we already have done a lot of these forces. We have to go and calculate the resultant force. And we also did a few of these examples in the extra classes, those Monday morning classes. So I'm not going to go too in depth with this again to explain it. I'm just going to do the example with the steps so you know how to do it again. So remember, the whole purpose of getting a resultant force is you want one force that is just as strong as all the other forces, so it can do the work of all of the others. Instead of using all of that manpower, you only have one person or one machine that's doing all of the work then for you. If you have a resultant force, you also get an equilibrium force that is equal but opposite to it. So it keeps it in a standstill basically. So if a resultant force like this is in a northeast direction, then your equilibrium will be in the southwest direction. Okay, so here are the 7 steps that we always follow to do this. I want you to pause the video and go write this down for yourself, and even the stuff that I showed you here at the top. Okay, so that you always have this with you when we're doing this work, and so you remember how to do this. All right, so this is the first example that we're going to do. So the first thing, before we even look at the steps, I want you to go number the forces in the system. So the 60 newtons, we're going to make number 1. The 120 newtons is going to be number 2. The 80 newtons, number 3. And my 40 newtons, number 4. Okay. So the first step that we have to do is to check that all of the arrows are pointing in the same direction. So if you look at the forces, this one is pointing out, this one is pointing in, and then those two are pointing out. But we want all of them to go outwards. So this is our problem as number 2. But the easy way to fix it is just to extend it the way that it was already going. So 120 newtons is going to lie over here now. My number 2 is now over here in this block. Just finish your Cartesian plane by adding in little lines. So you know that this is your x-axis and this is your y-axis. So if this is 45 degrees, the math rule says the angle that's opposite it is also going to be 45 degrees. So that we just know what these angles are. And then this one over here doesn't exist anymore. Okay, so there's 1, 2, 3, and 4 now. Step number 2 says check that all of the forces has an angle with the 0 degree line. So you guys know that when I started explaining these calculations to you, we always use the angles to the horizontal plane. And then you had to go and check which of them were positive and which of them were negative. Now, you can still use that method if you understand it completely fine. But for this example, I'm going to use the other method where we take all of the lines to my 0 degree line. So this is my x, which is my 0 degree line, because you can see that it's lying horizontally. Okay, so I'm just going to number these forces here to make it a little bit easier. Now, force number 1 is on the x, so on the horizontal, so that means that the angle there is 0 degrees. Force number 2 is going to have to come all the way from here all around to get to the 0 again. So that means we know that this line over here is a straight line, and the angles of a straight line is 180. So 180 plus the 45 is going to give me 225 degrees. So all the way from the blue to the purple line is 225 degrees, and this is the angle that we're going to use. Then number 3, from the orange to the purple, now you can see that there is a 90 degree block. Okay, so that means it is 90 degrees to the purple line, the 0 line. And then force number 4, we're going to have to say all the way from the pink to the purple, we know that from the pink to the orange is 30 degrees, and we know from the orange to the purple is 90 degrees. So 90 plus 30 gives me 120 degrees. Okay, so now we have all of the angles to the purple line, and now we will be able to do the rest of the work. Step number 3, calculate the horizontal components by using cos. And step number 4, calculate the vertical components by using sin. So we're going to do step number 3 and 4 together because we use the table method. So on the left hand side we do the horizontal component, which is x, and on the right hand side the vertical component, which is y. Okay, so remember we have 4 forces, right? So we have to do number 1 on both sides, then number 2 on both sides. You can write this in pencil or with the highlighter that you numbered, it's fine. Then number 3 on both sides, and then number 4 on both sides. Okay, so now we know that we have to do horizontal components for all of them and vertical components for all of them. Now remember I said with horizontal components to remember what to use. If you ate a lot of kos, remember in Afrikaans, food is kos. So as jy baie kos geëet het, then you want to go down, lay down a little bit horizontally and sleep. Okay, so kos, so the stomach is full over there, goes with horizontal. But we have 4 forces, so you're going to have to do cos 4 times. Vertical components, if you do a lot of sin, so if you're naughty, you go straight down vertically to hell. So sin on this side 4 times. Alright. Now we have to go and calculate this or put them in. Now I've seen a lot of you guys make the mistake by swapping around the values that you put on the front and the ones that you put at the back. Now if it's cos or sin, it doesn't matter. On the front, you always write the size of the force, please. And on the back, you always write the size of the angle. And remember, those are the angles that we're working with. So if you look at the first one, my first force, what is the size that I'm going to write in the front? It's a 60 Newton. But you have to do it on both sides. Number 2, the size of my force is 120. For number 3, the size of my force is 80. And then number 4, the size of the force is 40. Okay, so now we have all of the sizes of the forces that's written in front. Now I want the angle that it's making. Number 1 is 0 degrees. Number 2 is 225 degrees. Number 3 is 90 degrees. And then number 4 is 120 degrees. And you guys already know where I got those degrees from, the angles from. Okay, so when you get the answers, we're going to add them all up to get x, and on this side to get the y value. Alright, so let's put this in now. 60 cos 0 gives me 60. 120 cos 225 gives me minus 84,85. So you see automatically by using this method, it shows you if it's positive or negative, the answer. 80 cos 90. Let me just take this calculator out of the light. Is 0. And 40 cos 120 is minus 20. So to get the total x value, I have to go say, remember it's positive 60, so 60 minus 84,85 plus 0 minus 20. And that gives me a minus answer of 44,85 newtons. Remember, these are forces, so you have to write newtons. You don't have to write anything there, and please don't make a mistake there. Rather write the Newton answer here at the bottom. And if you don't write newtons there, you don't get the marks. Please don't make that mistake. Okay, then on this side, 60 sin 0 is 0. 120 sin 225 is minus 84,85. 80 sin 90 is 80. And then 40 sin 120 is 34,64. Now I have to add them all up to get the y. So it's plus 0 minus 84,85 plus 80 and plus 34,64. And that gives me a total answer of 29,79 newtons. Okay, so now we have our x and our y. So we calculated our horizontal and vertical components. Step number 5, we have to go calculate the resultant force by using Pythagoras. So remember, the whole part of this is to get the 3 parts of my resultant force. Number 1, I need the size of the resultant force. Number 2, I need the angle that it's working at. And then number 3, I need the direction that it's working at. So if you're looking at it in a diagram, the resultant force was 10 newtons. It's working at an angle of 45 degrees in a northeast direction. Because remember, 45 degrees can be in any block, but we know it's northeast. Okay, so we want to get this one first. Pythagoras. So my x is minus 44,85. Please remember to put the square in there, otherwise you're going to make a mistake. My y is 29,79, again the square. To get the square away from my r, I have to put a square root in, and I do it on both sides over the whole thing. But just because there's a square root doesn't mean that those two squares fall away. It's mathematically wrong if you take them away. So please just put this in exactly like that in your calculator. So we say square root bracket minus 44,85, close the bracket, square, plus bracket 29,79, close the bracket, squared. And that gives me 53,84 newtons. Okay, so now we know what the size of my force is over there. But now we need the other two things still, okay? So step number 6, calculate the angle of the resultant by using tan theta equals y over x. So tan theta equals y over x. My y value is, let me just move this up, 29,79, and my x value is minus 44,85. Now it's fine if you write the minus in there, but when you put it in your calculator, please don't put the minus in, okay? Because otherwise it might give you the wrong answer. So please just use it as a positive inside the calculator. The minus only comes in when we do the little freehand diagram. So I want to get theta alone, which means I have to get tan away. So I have to say shift tan, 29,79 over 44,85. And that gives me 33,59 degrees, because that's an angle now. Okay? So I know it's working at an angle of 33,59. But now I need the direction. So step number 7, draw a freehand diagram to find the direction and then write your final answer down. The freehand diagram that I'm talking about is the one that you guys know, this little diagram. Please just don't do it right, draw this thing ever in pencil, because otherwise they're not going to mark it. So this is x and this is y. So we know from our 0 point, anything to the right is positive of x, and to the left is negative. For y, anything up is positive, anything down is negative. So if you look at this now, my answer of my x is negative, which means it's going to be on the left-hand side, somewhere over there. It's minus 44,85 when you draw a graph. Y is positive, so it means it's going to be at the top, somewhere over here, 29,79. And if you connect the two lines now, that means my resultant force is lying over there. If you put in direction, north, east, south, west, my resultant force is lying in the northwest direction. So when you write the answer now at the bottom, you say the resultant force equals to 53,84 newtons, 33,59 degrees northwest. Okay. And if they ask for the equilibrant force, it's the same size, same angle, but it's in the southeast direction. So you write it like this: 53,84 newtons, 33,59 degrees southeast. And that's it. So go practice this on your own again, and then on the WhatsApp group I will give you some of these calculations that you have to go try by yourself.